Hello, everyone. Welcome back to Kids Python Challenge. Okay, let's continue our faster hunt for happy numbers. Okay, so let's see where we were last time. So we implemented improved version of is happy checker, right? So we did it first as a very naive, simple happy is happy function. Okay, let's run it. Let's go back to E4. Define the original one is happy like this, simple one. And it took, for example, to see, for example, to find up to, let's start from, the last time it took 17 seconds. So maybe we should do for 500,000. Okay, let's try 500,000. And it took, let's see, is happy. Okay, is happy is this one. Okay, very simple one. So it took around 9 seconds. Okay, and then we had an idea of using if one number, we found out that one number is unhappy, then as soon as we see that number in the process, maybe we can decide that it will be that the starting number is also unhappy, because it always goes to the same loop. Okay, so, and we implemented that using that idea, using if any number, if we find that that number is unhappy, then add it to unhappy list and keep that unhappy list and to see if we can do it faster. Okay, so let's make a box here and let's define is happy list and copy the same one as last time, for which we used for is happy one. Okay, and change it as is happy list. Okay, it's instead of, okay, here. So let's see the is happy list implementation for the case of 500,000. Okay, we thought it might be a faster. Yeah, it was faster because it took 9 seconds. The unhappy list version is 6. And then we found out that using a set will be a better idea and implemented a set version, which is like this. Okay, instead of using list, we use set. Okay, instead of using maybe this is good enough. If we find out a number is unhappy, we add it to unhappy set and use it. Okay, so in this case too, we again copy the measurement function. Oh no, not this one. Okay, the same one for 500,000. Copy it just below unhappy set, is happy set. Copy, define is happy set, which uses set instead of a list, and replace the decision function as is happy set and see how long it takes. Oh, it takes just 1.5 seconds, quite fast. And of course, we know that the answer is all the same. 14, happy rate is 14.56, 14.31, 14.56. So this is wrong. What's wrong? Maybe we will check that later. But basically, the original one, no, not this one. This is for 1 million. So, okay, let's compare it with the original one, which is case 72,786. Okay, 786, and the same for this guy. Okay, the answers are all same. So this is much faster than the original. Okay, that's what we found. Compare processing time. We did it. 1 million and 10 million. Okay, maybe it takes a lot of time. So let's take a look for 1 million first. Okay, so last time we tried 1 million and it took around, let's go back to the first one. Okay, the first implementation, if we change it to, okay, actually, let's try this way. For the sake of, we prepare a list of ulims up to, say, 200, 200,000, 500,000, and say 1 million. Okay. And we repeat this. Also, we prepare time 1 list as empty. Okay. And then we do it for, say, ulim in ulim list. And we do it with a tab. And lastly, put time 1L, append the result, this one. Okay, maybe we should write this way. Okay. So elapsed time equals this, and this can be replaced as elapsed and append elapsed. Let's run this and see how each one takes. Okay, in the meantime, copy the same work down to, say, set version. We'll skip the list version because it's too slow, and instead we make time, say, 3. Okay, and also copy. Is this still running? Okay, it's done. Okay, so remember, it's like this. So let's copy the part, the same part, down to set version, time measurement. And so we change the function name as this. And also instead we add it to times 3L. Okay, let's run it. And also, because this is very fast, let's try the 2 million and 5 million. Also, maybe 10 million. Okay, let's run this. Okay. So quite fast for for 1 million, it's less than 3 seconds. 2 million, it's like 6 seconds. Let's compare. Last time, 10 million was like 18 seconds. So it's much faster. Okay. It's like this. Okay, so while it is running, let's go back to the slide and see how to let us visualize the processing time for different approaches, make lists of ranges and processing times of isHappy, draw a graph. How about isHappy set? Compare side by side. Okay, so let's to do that. Okay, it's now over. Good. So let's copy. We don't need this, so just forget about it. So we have these results. Okay. Good. So let's see how we can visualize the results. To do that, maybe I'll put the code in the description box so you can copy. So it's from here, like this. Yeah, maybe you'd better paste it from the description box below. Okay, so first, let's see how we can visualize the set version. Okay, set version. So x axis is ulimL. And y-axis is time 3L. Okay, so let's see. Like this way, we can draw a graph very easily. Okay, it's like this. Very good graph. Okay. So if we use log for, say, only x, it looks like this. Okay. So let's overlay the original version on top of this. Okay. So it's quite similar. We can copy and paste. And instead of 1, let's see. For 1, it's only 200,000, 500,000, and 1 million. Okay, so the first 3, only we take the first 3. Okay, so we should change this as, okay, let's change it to red and use it up to top 3. Okay, let's draw it side by side. Okay, it's like this. Okay, so yeah, because it takes much time. The red one, the original one, is only up to 1 million, and it takes already 18 seconds. While the new version, improved one, takes only, say, 6 seconds. Okay. No, 1 million. 1 million. 3 seconds. Okay. This is time. So 3 seconds. So you can, this way you can compare by visualizing it onto graph. Okay. So you will see how you can do that. Yeah. Okay. Please find out. Please try yourself and how this is kind of plotted in your graph. If you use also log scale for y, it's like this. Yeah, also they are all, both are fine, but you can see the difference much easier this way too. Okay. So maybe it was very short, but this is maybe we can how we can compare the graphs side by side. And this is how we can draw time comparison graphs using matplotlib. If you're interested, please use the manual for this kind of visualization. Okay. That's all for today. Okay, so the homework is, let's see how we can go with isHappySet. And as we saw, we can go as far as 10 million within, say, 35 seconds, which is quite fast. So I hope you will see the effectiveness of improved algorithm. Okay, please come back again for another lesson. Okay, bye-bye.